at the same time, I will show you how to do something even more interesting, that is the interaction part, how to bridge machine learning outside Unity and to make everything inside Unity. And that is like one of the most powerful things, because uh, as I was saying, that today to do machine learning, you probably want to do Python. And to do Python, we know that is, I mean, you cannot do Python inside Unity. You need to do things with C#, but actually you cannot, I mean, you're only using models, but to basically tweak stuff and work more in depth with machine learning models, you still need to do this outside. So I will show you how to bridge this. And what do I mean by this? I will execute and I will ask you to install a couple of things later. Just let me move this. Uh, how do I move this to the top? Yes, here. We will implement a couple of things. And one of the things that we will implement actually is the same thing that I was showing you, but I need to change my camera, of course. So let me stop my video. Yes, so you see I'm getting the same results, same speed, but look what's going on here. We are getting the predictions in a different program. Here, you see this is detecting with high accuracy my key points. For the lines, we don't care about the lines. This is just for visualization. It's detecting my arms, it's detecting my wrists, it's detecting like the same points that my shoulders, for example, is detecting my nose, my eyes, my ears, and it's getting a little bit like it's doing like some flickering because I have like high brightness because of the reflections. The sun is coming in this direction, but that's okay. There are ways to smooth that. But what I want to show you with this, so I need to implement actually something that is called lerp. I will include that in the last in the code that I will upload, that it will smooth this flickering. But what is going on here? We are using a machine learning model in JavaScript where the code is like super simple, and we are transmitting data to a program. So we are receiving that information here, and that is super 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 useful because now we are like, let's say, platform agnostic. Uh, or we don't depend on one specific platform. So what you see here is my position, and I'm just doing here in Unity something super simple that if I move, actually let me move the camera so this is correct. So you can see that if I move my head to the left or to the right, I am controlling and I'm interacting with objects. This is a very simple yet powerful, because imagine the possibilities to interact, for example, with robotics, to interact with geometry, to make, for example, like a 3D modeling application using your gestures. And I'm showing you this because this is also part of what I do. If you go, I know that some of you follow me on Instagram or things like that. I show you this. This is part of the things that I mostly do, but my field of expertise is basically like in robotics and interaction, and I have like many things applying machine learning and doing like some interesting projects, such as this one, for example. This is hopefully something that I will publish soon as a paper, is how to interact using different sensors and machine learning models to generate uh, KRL code, basically like KUKA code. This is one of the robots that we have in here at MIT. We don't have like many robots. We have just like a couple of Agilos, very small ones. to generate that in real time, how to interact in a 3D environment, for example, to generate code in real time. So I want to actually do a couple of integrations after we see this with ML agents. So for example, here I'm training robots. Probably you have seen, I mean, I know that some of you have seen my videos, but what if you can train your robot based on your user input? So we will try to do this for the next session. But first, again, we need to program this. And in order to program this type of interaction, we need to get out a little bit from Barracuda. I mean, it's good that I show you this because it will be more developed soon, and you will see how this will grow a lot in the future. But also to do like this type of things, for example, here I'm controlling a machine and doing like a similar technique that I'm showing you right now to detect your pose, to detect your, for example, your hands, to detect your head, to interact with NC machines, numerically controlled machines, is something like super fun first, but also like super powerful for designers, for example, and creativity. I mean, this is what I do for also for my PhD. This is the project that I did 6 years ago in my master's here at MIT, and I've been developing like a couple of things along those lines in the past, I don't know, probably like 8 years now or 10 years in different scenarios with my workshops, in my school where I'm a professor in Chile. It's a School of Design and Engineering. So I will show you these techniques. But first, we need to take care of a couple of things. If you have any questions, please feel free to post them on the chat. The first thing that I need you to do is to, I will stop this and I will stop this, is to go to, let me show you my, is to go to code.visualstudio.com, code.visualstudio.com, and download this software that is called Visual Studio Code. You have versions, in this case also this is very good because it doesn't matter if you're using either Windows or Mac OS. And some of you might ask, Diego, why are you jumping now to do like another platform, or also like teaching us or coding something in JavaScript? And I have a very good reason for it. So while I show you this, please download Visual Studio Code. It's a very lightweight platform for developing code. What you see here, you can write code in any language that you actually want, and it's one of the industry, or like it's a standard thing right now. If you want to code in JavaScript or even do like Python things, you use this. Even though I know that some people use like JetBrains, PyCharm, or Atom, I don't like it that much. I think Visual Studio Code has everything right now. You can even integrate like Platform IO that allows you to write directly code to Arduino. It replaces the Arduino IDE. So download this, and I will explain you the reason. Because if you see, for example, like YOLO, most of the implementations are geared toward tiny YOLO that is limited and not that precise. But if you find some TensorFlow YOLO v3 Unity, for example, there is this example that is super fine. This is a guy that did it like almost 2 years ago. He implemented YOLO inside Unity. It works relatively like okay, and it's doing like a similar technique, the one that I just showed you with Postnet, and you even have the code. What is the problem here? He is implementing everything from Python, and he's implementing the YOLO from directly from TensorFlow and using CUDA. And CUDA is platform dependent. CUDA is a parallel computing platform and application programming interface model created by NVIDIA. So if you have an NVIDIA card, you can run that sample. If you don't have an NVIDIA card, you cannot do it. So that is a limitation. And you will find a lot of things like this, like the most powerful machine learning models, the more advanced ones, like using, I don't know, like style GANs and things like that, to generate content on the fly, they are dependent on this industry standard that is CUDA. If you have an AMD card, you're limited. Right now, for example, in this computer, because of a research, I'm using an AMD card. So I cannot run locally this. I need to go to Google Colab, as I showed you in the first session, and do things with that, but it's not ideal. So luckily, we have something that is called TensorFlow JS and other things like Chainer and other frameworks. But you can run machine learning models on a browser, and you don't need CUDA. So basically, these are ported models that you can also train and port to TensorFlow JS and use them with your program. So that is actually super interesting, because right now we can even run machine learning models in our phones. So that is always a good thing. So if you install already Visual Studio Code, you will open it. I will do the same thing. But while we talk about that, you need to install one more thing. I will put the links in case you didn't found what that is Visual Studio Code in the chat. It is different because Visual Studio Code is a lightweight implementation. So those are two separate platforms. Visual Studio Code is free. Visual Studio Community is more like full, let's say, application development. So basically, you have a solution, and inside your solution, you have projects, and you have like basically it's like a full IDE, like a full independent development environment. Visual Studio Code is not. Visual Studio Code is geared toward like more scripting, let's say, not specifically like app, like full program or app development. So let's say like Visual Studio Community is more professional. But for this case, and because of the things that we're going to use, VS Code is the solution that we want. But that's a very, very, very good question. The other thing that we need to install is called Nodejs. And I will put the link here, Nodejs. And Nodejs is, you will download this one that in this case, if you open it on a Mac, for example, or on a Windows computer, you will find this, download for Windows or Mac, and you will download this version here. It says like recommended for most users. You will download this installer, and it will download an MSI package, and it will ask you to install Node.js. So it will say a couple of things. You will press like OK, next, and it will install it inside a location. This basically you just press next, next. And one thing that you might want to do is check this one. When it says like tools for native modules, in this case, install something that is called Chocolatey, I think it's the pronunciation. And it's basically just like a command line that allows you to do like to interact with package managers and things like that. Because as we all know, or if you don't know, actually, the command line on Windows is terrible, like the terminal. On Mac or on Linux is beautiful, but here, yeah, you need to install something like this. So you will press next, and you will install all the things that basically that we need, right? I will press cancel because I already have everything installed, but you might want to install that. Why? Because today, and let me explain you with a small diagram. So let me switch my share screen. Today we will implement something. As I was saying, to implement the system, and the system will consist on a server, right? We will have, and that server will serve a machine learning model. And that machine learning model will be implemented in JavaScript because of, again, like we want to make this multi-platform, not platform dependent, and you can run it either on Windows, Mac OS, or even Linux. I know that some of you are also working on Linux for robotic purposes or things like that, working with ROS. So this could be also like a good thing. And this will run the machine learning model, and we will have a client that will run Unity. So the server will serve this machine learning model. Unity will ask for data to this machine learning model, and this machine learning model will send data to our Unity client. So that is actually super cool because in the future, if you want to implement like anything here, even if it's not a Unity client, but basically this is the only thing that you need to change in the future, right? The only thing to change or modify, because in this case, or basically like, again, this, I mean, in this case, we will implement today Postnet to detect poses, but in the future, you can basically implement like any model, but the engine that will send the information or everything will be actually here in the server. So you can use this or reutilize this many times. And we will accomplish this. So in the meantime, you install Visual Studio Code and Node.js. This will be possible by something that is called a REST API. I will write it here. Actually, let me change the thickness a little bit. We will use something called a REST API, where basically we will serve this API in a server, and we will have a client, and the client will generate a request, and the server will deliver a response. Right, so this is based on HTTP protocol, and it's super fast. It's easy to implement. It's like headache free, let's say, right? And that is very important because you will see like I'm one of the things that I like the most in terms of code is the interoperability between software. And you will see if you have used Grasshopper, for example, that in Grasshopper you have one of the standards for doing like interoperability, for example, is Firefly. Firefly is a software package or is a plugin that allows you to do like serial communication. I think it allows you to do OSC, communicate with Kinect, communicate with like joysticks and other things like that. You have other software packages just like Yeehaw that allows you to do UDP protocol, OSC protocol, that these two, for example, communicate very well with processing. Or even like for UDP, you can do Python. You have, I think it's Veng Est that has sockets that IO that communicates very well with JavaScript. But all of these implementations are kind of difficult, or basically you have options, but again, you need to be like very specific, or basically you need to tailor the solution like each time when you, sorry, not, when you, if you implement a server, for example, or a script, you can communicate with Grasshopper using these things. For Unity, you have similar things. This is on the Grasshopper side. For Unity, you have like pay things like HTTP, I think it's called fast HTTP, and like other like assets implementation that are usually that come with a cost. But luckily for us, like .NET, and I want to mark this, .NET has a very good implementation of this HTTP protocol. And again, if you know, probably you have used this, that's an advantage because both Grasshopper and Grasshopper or Rhino and Unity use C#. That is basically based on or uses .NET. That is the framework from Microsoft. So the solution that we will implement now will work for both Grasshopper and Unity. So we're basically like killing two birds with one shot. What we will do will allow us to do machine learning inside Unity, but also inside Grasshopper. So let's see how that works. I hope everybody installed Node.js already. If not, I will explain the last thing. So what is a REST API? So basically it's like a representational state transfer. So you can read this, and again, Wikipedia always works great. Oh, sorry, let me do the share of my screen. Here, Wikipedia. Representational state transfer. So this is a REST API. So basically, again, it's like a server just serving an API. So basically like a series of methods. But the good thing about this, I mean, if you check the diagram that I showed you before, that I think is not here, it doesn't matter. So basically it's like applied to web services. Like most of the web are based on in this type of architecture, where you have an HTTP method and different HTTP methods to get, to post, to put or delete stuff from a website or a database. So in this case, we will use like these two methods, get and post. I can point you to more resources about this. There is a very good one from Daniel Schiffman from the coding train. But if we look, for example, a representation of this, if we look at this image here, I will point you to this one. This post is like very, very, very nice. So it's exactly what I just drew you, like poorly drew with my poorly like drawing application. So basically you have a REST web service that we will implement now. You have an HTTP request from a client side, and in this case will be Unity or Grasshopper, and then we will have a response that will send the data. So I will point you to this resource now. I will put it in the chat. And again, trust me, this is like super nice for whatever implementation you want to have. And we will use Postnet, but we will implement, and I will show you how, from the ML5. So ML5, for the ones that don't know, is an initiative started at NYU, New York University, where Daniel Schiffman works. And they started this project to see how to port or make machine learning easier to use, especially for environments, lightweight environments, such as like mobile devices or web. So they basically made a wrapper for this. Basically, they wrap all the implementation of TensorFlow JS and made it into like a library that is very, very, very easy to use. So they also have like limited models, but those are like cool models. So they have also an image classifier, they have Postnet, they have body pics, they have UNet. So I don't know if this will work. So this type of architecture. Oh, let me. Do I have my camera on? Oh, sorry, I had it blocked. Let me reload this. So they also have like examples. Will this work? Probably, it's not showing anything. Anyway, they have style transfer. I will also put a style transfer. So basically, it allows you to take like any image and transfer that style transfer or that style to other image. You have pics to pics that allows you to, for example, draw something like a Pikachu and then transfer this to like any other models. You have variational autoencoders that this is the base, for example, to do like geometry. You have DC GANs, sketchRNN, they have YOLO implemented also, that is like super nice. I don't know if this will start YOLO. Yeah, they have an image, they have YOLO. So I will also put this sample in the script sections. So we will use this because the TensorFlow code is a little bit more complicated. It's more code. Here you can see that in a couple of lines you can implement machine learning models. And again, the idea of this workshop is to show you possibilities on how to implement machine learning inside Unity. We don't want to stick like to Barracuda, for example. But we want to use, for example, ML agents with the sample that we will do in the next session. So we will do a couple of things here. We will go through a setup steps that I have here to create this server, that the server is like super, super simple to implement. So I will move this here, and we will start coding our server first. So I will open a new Visual Studio. Let me close also my notes. I don't want to deal with that now. Let me move this here. So this is Visual Studio Code. This is the first thing that you will see on Visual Studio Code. Is a welcome screen. And one of the first step that we need is to create a folder where all the code will be. And this is super cool. This is good because what I will do now, I will share my folder on Dropbox. So if you are behind with the code, I will continue save all the things that I code inside that folder so you can access the data that was just coded. It will be like in real time. It will show like in real time the code. So the first things first, I will create a folder. Actually, I will open a folder. So you go to File, Open Folder. And in this case, I will go to my Dropbox, PHDMIT, Spring 2021, Classes, Unity and ML, and this is the session 3. Session 03. Not 1, sorry, session 3. And I will create another folder. So you can create the folder before, or you can do as I'm doing, I'm just creating on the fly. So this will be our server. And you will enter the folder and then you will say select folder. So again, I just created like session 3, server, select folder. So you have here an explorer that is pretty similar to the Unity hierarchy tab. Let me again start my video because so you can see me as well. So we will start the server. And the first thing that we want to do, we want to create a specific structure for what we want to create. So we will, if you go to this where my cursor is, you will see that you can create a new file, you can create a new folder, you can refresh the Explorer because it will be reflecting in real time the contents of that folder. So we will create first a new folder. It will be called public. Because we want to put everything that is public, basically everything that will be visible in our server, in this folder. So once we create this, we will put a couple of files. So the second thing, we will create a new file. If you click on public, if you see the arrow pointing down, that means that you are in that folder. So we don't want to be in this folder now. So you click again and the arrow will point to the right. And here, just like in the root folder, we will create a new file that is called index.js. Index.js. So you see that when you create a new file, automatically it points you to the file. It identifies what is the language of this file. And don't be scared because we are jumping now to a new coding language. JavaScript is, it has like, I don't know, like weird stuff, but it will make sense now that we have done like C# and some Python. So don't worry about that. So before we do stuff with our index.js, we need to actually start and create our server. Basically, we need to install a couple of things. So if you already installed Node, we need to make sure that some things are actually working. What things? If you go here to the upper menu, and if you go to terminal, you want to start a new terminal. So basically a terminal is this. A terminal is just like a command line where you can do, I don't know, like check the content of a folder and things like that. When you create a new terminal inside inside your folder, like Visual Studio Code, if you select new terminal, it will show you the path, the file path or the data path where you are. So in this case, it recognizes that my root folder is at, in this case, in my case, Dropbox from MIT, PhD MIT, Spring 2021, classes, Unity and ML, session 33, and server. So that is my root folder. So I can write things like dir, D-I-R, and it will show the content. So it shows here that I have one file that is called index.js, and also a folder, this is what it says like directory here, called public, right? So we are seeing this. But the good thing about doing this is that now I can say, for example, node -v. So if you write this node, N-O-D-E space -v, it should tell you, or it should give you the version of Node.js that you have in your system. So in this case, it says that I'm using 14.15. So I'm up to date, actually. I mean, probably the one that you will have is 14.15.4. I have the 0, so probably it will ask me to update or whatever, but it doesn't matter. If you have like a version like similar to this, you're golden. You won't have any problem. So remember that install Node.js, then start Visual Studio Code, create the folder, create this, create also this here. And I will do one thing. So if you right click, for example, in the file index.js, you can say, for example, here, reveal in File Explorer or show in Finder in the case if you're using a Mac. I am a hardcore Mac user. I'm a fanatic of the Mac environment, so I prefer Mac to Windows. The good thing is that it will show you the files in your folder. So you see this is the same data path that I see here in my command line. What I will do is that I will share this session 3 folder with you to see, not to modify. So you can, so basically you want to download the file or query the things that are here. So if you're behind, you can catch up. So I put it in the chat, and if you open this link, it will point you to this, right? You will see the files. Okay, so we're ready to start doing our stuff. So again, make sure that when you write node space -v, you get that confirmation that everything is working. All right. Let's code our server, and that will be the first part of our class because it's the most difficult one. Not the most difficult, but it's probably like the one that takes more time to understand. So the first thing that we want to do, we have our index.js. Actually, we should call it server. So let me rename it. Server.js. It's more professional to call it server. We will start by saying something that is called npm. What is npm? npm is the node package manager. You can install like a lot of things or dependencies that are called in your system, aka libraries. And for JavaScript, they work through this specific package manager that is called Node. You will find a lot of things like, and I need to explain you this. Sorry that I said that I was going to start. So you have things like Anaconda. Anaconda is also something that allows you to create environments for Python, meaning that you can install, for example, like different versions of TensorFlow, PyTorch, or different Python versions, like Python, like the deprecated one that is 2.7 to, or another one have like Python 3.6. So different Python versions. Oh my God, always these notifications. So it's not showing, oh, here. So you can have, for example, with Anaconda, like different environments and different libraries. So for example, here I have something for the digital future workshops. I will point you also to my YouTube channel so you can see these videos. So the thing is that I have like a specific Python version and a specific dependencies here, like ML agents and stuff like that, that only work for those purposes to use, for example, like implement ML agents. I have things to have GANs. So here I have like a specific version of Python and TensorFlow, like TensorFlow 1. Now TensorFlow 2, for example, is the official release. I have things with PyBullet that allows you to do robotics in Python. Or, I mean, like a lot of things, like to implement also like RRT, those are path planning algorithms, to do like the conversion from Keras to OONNX models, and like a lot of things. So all of the things you can install in a specific environment. And for JavaScript, you have something that is, so basically, if you want to install something with Anaconda, you say like conda install, I don't know, but I will write like whatever. So if you have a command line like this for Python, it will start Anaconda, and basically it's a package manager, and it will install your dependencies. If I do, for example, pip, that is for also for Python, I can say like pip install whatever, and it will start a command, and it's telling me that ASD doesn't exist. But if I write, for example, install TensorFlow or install, let me do like NumPy. So it says that I already have NumPy on my system, and I'm using Python 3.9. So these are for Python. For Node.js, we have something that is called npm. So we want to write now npm init that will do something like this. So it says this utility will walk you through creating a package.json file. It only covers the most common items and try to guess sensible defaults. So what does this mean? So if we want to create a server, first we need to also specify a couple of things. What dependencies are we going to use? And it will create a JSON file that is in a specific format file that we will understand once we implement Postnet and send the data, that will have a specific information about that. So package name, we will call it server. That's fine, server. We will press enter. The version, you can specify, oh, this is version 1, version 2, version like whatever. It's our first version of our server. If you want to keep track of the versions, you can post it on a I asked, I said, sorry to interrupt. I'm wondering, is that that navigator only for Anaconda, but not for Miniconda. That is for Anaconda. You can install Miniconda separate, but I mean, Miniconda is just like a lightweight version of Anaconda. It's like the same. So if that answers your questions in the chat, yeah, good. I mean, Miniconda is like the same, but it's just like a lightweight version with less functionality. When you install Anaconda, you install also a Spider and Python notebooks and a lot of things that probably you don't need. This is why it's called Miniconda. So in this case, again, you just in the name enter. If you want to pull this to a GitHub repository, you can track the numbers. If you make modifications, you can call this like 1.01, and then if you make like a major like overhaul of your server, you can, I don't know, say that this is version 2 because this supports things that version 1 don't support or whatever. So we will say like okay. And description, you can write whatever you want. You can press enter for all of these things, but this is a server for ML models in JS. This is a description. And the entry point, and this is super interesting. Here is asking us for the entry point. And in this case, it's already pointing to server.js because this is the file that we have here. So we will say like enter. You can change this if you have another file, but in this case, server.js is okay. Test comment, we don't care about that. The Git repository, again, if you want to pull this to a Git repository, that's fine. We won't use that. Keywords, we don't care about that. The author, you can put your name. My case is my initials. License, you can say that this is MIT license or whatever. And then it shows you this. This is basically a JSON file. A JSON file is like a dictionary where you have keywords and values. So the keyword here is name, the value is server, the keyword is version, the value is 1, and so on and so forth. So this contains information about our server. So we will say okay, and we will have now something that is called package.json, right? Once we have this, we need to install one more thing that will be useful for our server. So I will write CLS to clear the terminal. And now we need to install something that is called Express that will make our life easier. So to do that, we will say npm install --save. Npm install express --save. This is what we want to write here. So I will put it in the chat also, so you don't, this is the command, you can just like copy and paste it. And this will start installing. So you see this is a package manager because of that. If you get like warnings, that's fine. If you get an error, something is wrong. And it will appear here with red. So in this case, something happened, right? It says that Express is version 4.17.1, and it added 50 packages from 37 contributors and audited 50 packages in X amount of time. And it found server vulnerabilities, right? So you see now that inside our server, we have a lot of folders here, right? You have like these folders here that have like functionality of Node. These are Node modules, like libraries that we can use. So if we did this, we are ready to start writing our server. That's all that we need, right? But one more thing, if you go to package.json, you will see that now you have one item here in our package.json that is called dependencies. Dependencies are the libraries that are needed to actually make your server or your program, the program that you're making, work. So in this case, it's just pointing that we have Express install. Let me see if we have another dependency that we want to install. I don't think so. So I think we're good to go. So let's start coding our first server. I will go back to my server.js. If you click once, it will open the file. And we will start building our server. First, we need to tell our server that this will be an Express application. Type of application. And for that, we will say const. This is a JavaScript is not a strongly typed language, so you don't need to specify if something is an int. It's like similar to what I explained in the first session in Python. It only has like a couple of keywords like let, var, and const for variables. So in this case, we will say like const. We will open curly brackets, JSON equals require Express. So this is a way to tell so we will use like this functionality of like JSON files to read and manage JSON files using like Express. I don't remember if this is strictly necessary, but whatever. We will just leave it like this. I don't remember because this is some example that I used like a year ago for another class. So probably there was a reason why I put this. The one that we want actually is this one, const Express equal require Express. So what is this require thing? This is similar to saying in Python import a library, or in C# using a library. Remember we were having like using Barracuda, using Unity Engine.ui, using ML agents, or whatever. In this case, we haven't done ML agents yet, but we will in the next session. So this is constant Express require Express. And now we will create our application saying const app Express. So with this, we're creating a new Express object that will allow us to actually make our server work. So this is just like the basic import. And now we can say a couple of interesting things. We can start our server by saying app that listen, and with this, for example, if we say 3000, we will tell our application to start a local server. So what a server is, like if you go to google.com, you connect to the server of Google. In this case, we're creating a local server that is not public, it's not out there in the web, it's just a local server that we can use inside our machines. So this is a typical thing with Python programs and also like JavaScript programs, because sometimes you want to serve things inside a server in order to manage like requests and things like that. So in this case, we're creating a server that will use the default server address, that is 1.7.0.0.1 in the port 3000. So usually also when you connect to Google, you're assigned to a specific port that is automatic, but here we will force everything to go to that specific port 3000. And with this, we will create an anonymous function. Oh, sorry, this is 3000. You can write whatever number you want here. Like 8080, you will find like, or 1234. We will just leave it in 3000. You can write like 5000, 55555, like whatever. In this case, 3000. And we will add an anonymous function that this anonymous function will do. This is the way that you express, basically you create a callback. Again, this callback idea is that when you execute this, you will also call, if it works, it will execute a function that you can code immediately here. This is why you use, like in this case, an arrow function. And you will say like console.log listening at, we'll say localhost port 3000. What that this means that once you start your server, the server will plot a message here in the terminal saying that, oh, good. If everything works, of course, we are serving in the port 3000. So that is actually super cool. Now we need to tell our server, okay, when I start the server, what are you going to do, right? In this case, we need to serve, or we need to look for an entry point. So we will express this entry point by doing the following thing. So this will start the server at port XXX. Replace with any number that you want. So you can have like many servers. So this is why you can have one server at port 5000 or another server running at the same time at port 5001, or and so on and so forth. So here we will say that app.use express.static, and we will say that public. So with this line, we tell the server to look for the entry HTML at the public folder. So we will actually implement our Postnet in that public server, right? So basically when we enter the server, it will look whatever file that we have inside that public thing, and it will try to execute it. And usually it is through an HTML file. We will do one more thing. Use express.json. For the ones that don't know, also JSON stands for what is a JSON file? It's for a JavaScript object notation. Again, Wikipedia has all the information, pretty accurate for this technical stuff. It's JavaScript object notation that is a format for data exchange. Super used, super popular. It's like very powerful also. So we will say like app.use parentheses express.json. And here we will just set a limit. So we will open curly brackets. We will say that limit dot in 1 MB. 1 MB. Sorry, I was missing one parenthesis here. Yeah, that is. So it's app.use open parenthesis express open parenthesis open curly bracket limit colon 1 MB for 1 megabyte close curly brackets close parenthesis and close parenthesis. So we will set a limit for file size transmission. Otherwise, we could be like also like crashing our server if we set this like to a very high value. So let's do one thing. Our server is almost done. So we will implement a an endpoint. So basically an endpoint, it means that if we connect to the address for example, this is http:// 1.7.0.0.1 2.3000. So if this is our server address, we can specify an entry point, sorry, an endpoint to say that this is API. So when we, with our software, when we make a request to our server, we can point to this specific endpoint to get a response. So we can say that this endpoint will only give us information about, like, I don't know, image data or post data or things like that. You will understand it in a second if you're a little bit confused, but that's fine. We will have a break probably in like 30 minutes. We will finish this server side in, yeah, less than that, I think. The code is fairly simple. So we will say it here, create an endpoint. Well, I already put that, sorry. And we will say that app.post, and we will call this, yeah, like API, that's fine. And here we will do the following thing: request, comma, response, and we will use the arrow function. We will open curly brackets here. The syntax is a little bit complicated, so basically it's like app.post. This is a post method that is called API. So basically this will be the address to actually do stuff with this endpoint. Request, response are the two, let's say, arguments that you or things that will be necessary for this post. You will get a request and you will post a response. So the client will make the request and you will send a response. So what we want to do, if we open the curly brackets here, first we want to know what is the content of a request. So if we do console.log, this is the analog for debug.log in Unity. So we will ask that if we get a request, we will plot here in the terminal. It will show us what is the information that we're getting. So we do that by request.body. It will show what is the information that we're getting now. And here we can do, what can we do here? So we don't lose time making like toy implementations. We will do one thing. We will create the variables. So we will create one variable. This is the way that in modern JavaScript languages you declare a variable with the let. There are other options to use, for example, var or constant, if this is a constant. In this case, we will say like let x, just like it, just to store some values, and another one that is called let poses, because that's the thing that we will send to our clients, the poses of our objects. So yeah, the poses, this will store post skeleton info, and this will just read or store the request information. So we'll do something that it might look kind of weird, but that's fine. So let me see, what can we do here? Oh yeah, we can say that X equals to request that body, and we can say that poses is equal to X. So what will happen here? With our ML application, with our Postnet application that we will code next, we will call, basically we will make a request sending the skeleton information. So let me just draw this so you understand what is going on, because this probably is the hardest part to understand and what we're doing today. Let me switch to my drawing application. All right, here. So our server, should hold my screen. Our server, it has this endpoint called API, and we will have our ML application that will act also at the same time as a client. This is a little bit like weird, but basically we will use here Postnet. So each time we detect a person, this application will send a request to our server, but that request will at the same time, basically you need to make a request to ask for information, you need to send some information. So this will send a JSON file with post data. So the server basically will get that request, right, with the JSON file, and we will assign that JSON file, we will store that information in the post variable, like we said, like let equal to post. We will read, sorry, first that JSON information, we will read it inside this X value, which should call it like data or whatever, and then we will assign post to that. Basically, the value of X, we will assign it to post, because then we want to implement another endpoint that Unity can use to actually read the information that we're getting. So we will have Unity, let's say, communicating to another endpoint here that we can call API2, and Unity will send that information with like a toy data, let's say hi. This is what we'll send with Unity. Unity will send hi, and then this API can post, basically can send the post information, and Unity can get that. So it's a little bit like tricky, but let me also like oops, I made like a line that was not supposed to be there. Oh. Let me move this. So to see like the picture, we will have server. We will implement two endpoints, API and API2. You can call it like whatever. Actually, we should call it like API1 and API2. So we will have this server executing this machine learning model. And should I do it like this? No, actually, let me do it like this. So you understand the diagram. This is Unity or Grasshopper. This is the server serving this HTML that calls this ML Postnet. So inside this Postnet model will send a request, call it R, with the JSON information, with the post JSON information. The server, when we make that request, the server will answer through this endpoint here, just with a success, for example. So basically, this calls the server and sending this information, the JSON, the post information data, and the server will just tell our ML Postnet success. It worked, fantastic. But we implement this in order to so the server can store. Let me do it with actually a different color, so it's like more organized. Let's do it with this color here. So all the post information, all the posts are stored in this variable, right? So that JSON will be stored in that variable there. And then from the Unity side, we will make a request, but now to the endpoint API2, and that request will only send the information hi. It doesn't matter what information we send from Unity. We just need to send something so the server knows that, oh, there's a guy like requesting information. And what does the request say? Like hi. So basically with that, you can send back to Unity as a response the post JSON. So basically a file with all the information. So that's the way it works. We're having like two functions or endpoints basically. One from the Postnet model that sends the data information, and then another one that sends it or broadcasts this information to the Unity client or Grasshopper. So let's see how can we complete this. Let me reshare my other screen. If you master this, you will be able to do pretty much whatever you want with any software. That's the beauty of this technique. So you can send information to like a microcontroller, like an ESP32, Raspberry Pi, Arduino, Yun, or whatever that connects to like internet, for example. So in this case, console.log, we will call this like in or data in. Let's call it data in instead of X. Remember, all the information is being synchronized on the fly. So if you get stuck with your code, that's fine. We haven't executed anything yet, so we don't know if this is working or not. So this stores the information from the ML model. In this case, JSON file with detected poses. Again, in the future, you can implement like any model that you want. You just need an application that connects to the server, and that's it. So data in is equal to request.body, and we will say that poses is equal to data in. This stores the information from the ML model into a poses variable. So again, this is very important because now we are ready to, and actually the response can be like yeah, we didn't have that. Like we need to implement the response. Now, actually, we said that we're going to call this API 1. We will do a second. I put this here and here. Okay, that's the way you write it. Now we will say like app.post. We will call this API 2. We will do the same thing, request, response. In this case, they are called the same. Oh, sorry, this is response. Request response, because these are like local variables for this function. So it doesn't matter if you repeat this here. It's a scope type of thing. So we did this. We will open the curly brackets. And here we can write something like pretty similar. So we can have a local variable like data, whatever. Probably there are cleaner ways to do this. So if you know how to do this, don't yell at me. I mean, this was an old sample that I'm like reusing in order to make this more interesting. So here we can say that request that body actually we don't need this. Yeah. So let's call this data from client. And we can say like data from client. So basically this will receive the hi. Let's say like the handshake from Unity or Grasshopper. We don't care. We are not going to do anything with that. We are just going to say the following: response, and this is something more elaborate, that JSON, and we will create a JSON file here. So we will do this. We will say respond.json, and we will create a field called status, and we will call this success, comma, and we will say that A is poses. So what is this thing doing? we are sending, we will get here the hi from the Unity client, just something that is requesting information. And if we get the information, we will respond to that request, sending this, sending a JSON file that says that, okay, we're getting the data, it's a success, we're transmitting data, but also it will contain the information of the poses, of the skeleton that we are getting. So that is the syntax is a little bit weird, I know, but this is the way you do it. So basically what we did here, all of this is the way that you express a JSON file, right? So then this is a keyword. So then you just said, oh, give me the status value, and it will give you success, or give me the A value. It will give you the poses. So with that, actually, we are done with our server. We will finish, yeah, this is the server part. Now, let's implement the public thing. So basically the HTML. And this is not complicated at all. I will do one thing. I will just, for the sake of time, I will create a new folder here. Sorry, a new file that I will call index.html. And I will, I'm posting this, this thing here. So let me clean this because it also has like, actually this is B Pro Skills Workshop, just to call it like that. So, what can we do here? Let me put this HTML file, just in case, also in the Teams folder, so in case you don't have a Dropbox or whatever. Because this is like trivial, like the implementation of this HTML file is just like standard. You can copy paste this code from whatever. But I will put this files, no, Teams, Unity machine learning, files, code, new folder, and this will be S03. And you will find this index.html here. It will try to open this, it will give you an error. I mean, just download the file. And you will download the file and you will put this file in the server.public. Right, again, this is not in the important part of the code. This is super trivial. This is just like a code snippet that you can get from whatever. Actually, I can even, actually I can, yeah, delete that. Let me just replace the file actually, now that I cleaned it. Close. Would it ask me? Replace, okay. Good, now this is the file that we want. So just a quick explanation. This is an HTML file that has like a structure, basically the div, the title, it will show you that a title that will say like whatever, like your application, my fair application, whatever. It has like dividers for a webcam container and a label container that we can modify. It's not important again. The crucial parts of the script are this. To implement in an easy way our ML5, sorry, our ML5 model, we will use p5.js. Sorry, that's not the way that you comment HTML. We will use p5.js. So to use p5.js, we need to specify or to import inside this HTML the libraries. So the way that you do it in an easy way, you just tell this HTML file, okay, go to the internet and load this file here. This is the p5.js mean.js. And just in case we want to also do with the other file, the p5.dom.mean.js. So you will have the p5.js library. What is p5 for the ones that don't know? p5.js. p5.js is the processing implementation for the web, right? So if you go, you will find like a lot of information, and one of the information actually is in the get started page, and it shows you exactly what we just wrote here, right? The way that you need to, I mean, actually we can replace, you just need to copy and paste this. It's the same thing. No more complicated than that. And with that, you will have like the basic functionality of p5.js. That is basically processing, but instead of being written in JavaScript and in a local software in your computer, you are writing everything in JavaScript, which is a different language, and you can serve it on the web without any problem. So this is now the standard. Like processing is slowly fading away and disappearing. That's my guess, but probably not. I mean, processing is still like super useful for a lot of things. So we will use p5.js, and also we will implement, we will import ML5. So ML5, you implemented with this line here. So again, also it calls the ML5 library directly from the web. And this will allow us to create a machine learning model. And we will just like, this is optional actually, the ID, like loading the model, we can change it also later. If you don't want your website to say anything, like whatever, get rid of that. The important part is this line here. In the same way that we were loading JS files, the libraries from the internet with the JS, with this address, now we want to load a local file, a sketch file, or whatever you want. We can call it actually postnet.js with this line that basically is script, source, and point the name of the file. And for that, we need to actually create a new file that we can call postnet.js. So what is happening here? When we start our server will go to the public folder. It will look for the index.html, which at the same time will import the necessary libraries, and it will import this postnet.js file. Whew. Okay, complicated, but not that complicated if you watch this video and train it again. So trust me, this is the way you do. So let's take a break of 18 minutes. So at 3 London time, 10 Eastern time, we will return to implement the postnet and the final part in C#, and we will have machine learning running, and then I will show you how to run other models if we have the time. So this is like pretty exciting because we are about to do something like very, 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 very powerful that will help you a lot because it's platform agnostic, and you will see the benefits of doing this instead of using Barracuda. Or sometimes you can use Barracuda as well. So I'll see you at 3 London time. All right, I'm back. I hope you're there as well. So let's finish this ML model. Again, it's good that I'm showing you like different possibilities because there's no like one truth in this implementation of or this let's say development of ML, especially for design scenarios. There's not like one ground truth. Sometimes you need to go through this type of tricky stuff, like implementing servers and clients and things like that. So this is pure gold. I'm sorry that I'm telling you this, but what I'm showing you now, it's fantastic. If you learn this, you won't have problems like implementing anything. Of course, it's practice. You practice, you practice, you practice, you get better. I've been coding for 16 years. In case you're wondering, I'm 40. So I started coding when I was like 24. I'm 39, but when I was like 23, 24 years old, doing Rhino script. That was the language that I was using at that time when I was an undergrad in architecture school in my country, Chile, without all the beautiful resources that you have right now. YouTube was not a thing, and web resources were scarce. So just so you know. Okay, so let's do our famous Postnet. The code it's fairly simple. I will try to go fast with this so we can implement it and interact with the server, and then we will do the Unity part. So Postnet implementation in JS. So the first thing that we need is specify a variable for video, a variable for Postnet. So if we go to what is Postnet, you can find, like, especially on Medium, like real-time human pose estimation. One of the most famous ones. There are other more advanced, but basically you can get like key points like your knees, your ankles, your wrists, elbows, shoulders, and things like that. It's one of the most famous Tensorflow models out there. So we need a variable to store the video information, the model information, and also what is the output of this model, that are the poses. So we will declare an empty array to store the poses. An array is basically like a list of grasshopper containing data, like in order, according to like a specific index. So again, the code is fairly simple. So we need to create two functions. We need one function that is like the setup. If you're familiar with processing, this is like, you need two functions. One is the setup, and the other one is the draw function. Sorry, it's with minor case. So just like the analog to Unity, this is the start function in Unity, and this is the loop function, the one that is the update function in Unity. So basically that's the analog. So this executes once at the start, and this executes constantly every frame. So this repeats in a loop. So because we're writing in P5.js, this is pretty similar to processing. We need to create a canvas, and that canvas will be 640 by 480. those are the only arguments that we need to pass. So this creates a canvas to show stuff. We will say that video is equal to capture and video. Again, I'm saving everything in the Dropbox folder in case you're left behind. So basically, we assign the video capture stream to our video variable, and then we can set the size of the video. We can set video that size. This is a method from the video object. We'll say that this is equal to width and height. What are those numbers? Width and height are 640 by 480. So basically, we will squeeze our video to the canvas size. With that, we are cool. We're good to go. So let's see if actually this works. So we will do one more thing. We will hide our video in the setup function because we will draw our video in the image, in the draw function. So we will say image video 0.0. So basically it will be on the corner, on the left top left corner of our canvas. So basically it shows in our canvas. Width and height. Why are we repeating width and height? Because here we're just preparing the tensor for the prediction from our video, and here we're just like doing the squeeze operation just to show it. So let's see if this works. I will save this. And how do you see if this works? Actually, I will turn off my camera so I don't get like an error from Zoom, from our program. So now that we have this, because I told you in the past part, in the first part of the class, that we will execute our server. The server will look inside the public folder. It will look for HTML file, and the HTML file will execute postnet.js. Right now, the only thing that this postnet file is doing is just showing the video. So let's see if that works. How do we do that? We go to the terminal, and in the terminal, we make sure that we are in the right path. So the right path in this case is we are at the root folder. The root folder is server, and we say node server.js. And we see that we get a message. That message is listening at the local host port 3000. So that is the message that we implemented here. So let's see if this is working. So if we go to a browser and if we paste this information here, like http://127.0.0.0.1 colon 3000, we see that our it's actually reading the HTML file, because it's giving us the title, detecting post in video feed B Pro. So let's see what is wrong here. So probably it's because I'm using Firefox for this. So let me go to browser console. This is giving me an error. Oh, let me execute this in Chrome to see that this is not, to make sure that this is not giving me any problem. Okay, It's working. It was not working because of Firefox. So you can see, if you see my screen, is reading the actual feed from my webcam. So right now this is working. These are good news. One thing that we need to implement is, or we need to do in order to see if we're getting any error, because sometimes it will show you just that, detecting post in video feed B Pro. If you go to here, I mean, I'm using Chrome. You can do it in Safari, but probably for this type of things, you want to use Chrome because it's the most compatible. So you go here next to your picture if you have a Google account, then you go to More Tools, and you do Control Shift and L, I think it is, or I. You choose Developer Tools, and you will find this thing right here. This is a console, and this will show you in case you have any errors. But also, what this will show you is the following thing. I will go back to my Postnet file. So I will, for example, do something here. We will say console.log. We will say starting Postnet. We will send a message just to show you how this is working. So I can restart the server. With Control and C, I stop the server, and I can run it again. Node space server.js, listening to the local host. This is an address by default, by the way. So you see now I refresh the website, the address, and here you can see that console.log output. You can plot the content here in this actually is here because my camera is inverted. It's like next to. So that is actually super cool because now we can see messages here, and we need these messages to see what we are sending and what we are receiving back from our server. So now that we know that this is working, we can just stop our server, and we can continue programming our client, because the server is just serving, right? It's just like giving us, yeah, let me close that and resume my video. So the server is just like showing us the camera. So let's implement after video, load ML5 Postnet model. Again, ML5 is similar to Barracuda, but for JavaScript. It allows you, basically it's a wrapper for Tensorflow JS, but allows you to load Tensorflow JS models. In this case, the library comes with Postnet, so you don't need to do anything. But if you want to load like external models, you can load those as JSON files. Again, Daniel Schiffman coding train is the most amazing resource for learning this type of things. But those takes a while to learn. So we will create a Postnet, load and create the Postnet model with a single detection. So it detects like one person. We don't need more for now. So we will say like Postnet is equal to ML5 dot Postnet, and as arguments we pass the video, and we will have a callback function that is we'll call model ready. What is a callback function? So when we create this, basically we're telling like load, create the object Postnet with the ML model, use the video basically as your input, and when it's done, you will execute a function. This is a callback function. You will execute a function, And that function, it will be very simple. It will be function model ready. And the only thing that this function will do, it will say, let me see. Actually, in my HTML, yeah, I can have this ID status. It's just a text that says like loading model. I can uncomment this. So I will do two things. I will say like select hashtag status dot HTML, and we will say model loaded successfully. You can comment this in case you get any error. I'm just putting, so basically what this will do, it will get the object, it will by the tag that is called status, and it will change the code, the text that by default at the beginning is loading model to model successfully loaded. But also, in case we want to check if the model was loaded in our website, like in the console, we can say console.log model loaded. Actually, we can copy and paste the same message. Why do we need this? We need this to actually know that if the model was loaded correctly or not. If we don't get this message, for example, in the console, we know that there is something wrong. So we will leave it like this. So this is the callback function that it will be called if the model was loaded correctly. And now we need to do, actually, this line should be here. Yeah, this is the order of the code. After Postnet, we will say that Postnet.on, basically when it's being executed, pose, basically to give us the type of output that we want. We want the pose, and we will have a function here that will get the results. This is the syntax. Again, it's a little bit weird, but equals results. What is this chunk of code doing? This is doing the following thing. This is, let me organize the code so it looks like, this is saying that execute the Postnet object, start detecting poses, and you have a function here, it's a callback function that it will get the results and it will assign the results to the variable poses here. That's the only thing that this is doing. And that's okay. So then we just hide the video. So we don't want to show it in this function. We're doing everything here. So now we need to implement one function that is called, we will only do to draw the key points, not the lines. Then I can show you the code for that. We will have a function draw key points, and this function will draw like the points of the eyes, of the nose, of the ears, of the shoulders, and so on and so forth. So to do this, we will do a for loop through all the poses detected, and we will say for let I equals 0, I less than poses.length I plus plus. So this is a typical for loop that basically will iterate in case we have like more than one pose detected. So it will check, okay, you have one pose, two poses, so you will loop through all the poses. So if you have one pose, basically it will iterate from 0 to 1, then basically only one time. If you have like 5 people in your camera, it will go from 0 to 5 to 4 actually, 0, 1, 2, 3, 4. And inside this, we will say, for each pose detected, also again, like this is like very standard code for the pose and drawing things. You can find this code like everywhere. Different versions, but basically it's like everywhere. With minor modifications, but so for each pose detected, loop through each key point. And here we will say that let pose I. So basically, if we get like more than one pose, we will access that pose with this index here, this iterator that is I. So first it will do pose 0 detected, then pose 1 detected, then pose 2 and 3 and 4 and so on and so forth. So this is let pose equals to poses with the index at the index I that pose. This will store one pose per loop and to the pose variable. And here we do another for loop, so I will copy this. So we need, and this is a nested loop. But here, instead of saying I, we will call this J. So this is a different iterator. And here we will change this. So we will say that for J started at 0, while J is less than pose that key points that length and at each loop increase the value of J in 1. So it will now, why did it do this? So it's like this. Pose that key points that length. So if it detects 20 key points, it will iterate from 0 to 19. If it detects only like 2 eyes, a nose, and 2 ears, it will be 5 key points. It will go from 0 to 4. So here we will say let key point, not with uppercase, sorry, let key point equal to pose that key points at J. So each time, basically, if it detects 5, it will assign key point the value of each key point to key point of all key points to key point once per loop. Right, so for example, if it detects one pose, then it will enter this nested loop. So it will go through all the key points to do something. And that something is something very simple. We will say if key point that score is bigger than 0.2, we will do a fill. We can do like 255.0.0. That's a color. We set the color of the key point. So what we're doing here is, if the confidence of the model says that the key point, or sorry, if the confidence of the detection of the detected key point is more than 20%, draw the key point. So sometimes you might want to reduce the flickering by increasing that number. So if the confidence is more than that, you will draw the thing. Here we will say like we don't want a stroke, we don't want like line, we just want to fill a circle, and we will draw an ellipse. And for that, we will say that key point, that position, that x, key point, that position, that y, and the size, let's say like 25. So this is just creating at each detected key point draw a circle, if this condition is, of course, met or fulfilled, right? With that, we should be able to visualize our pose. So let's start our server. Let's start here. Sorry, not Postnet, it's 127 blah blah blah. Oh, it's giving me the error that I have my camera. Let me stop my video. Let me refresh this. Oh, I forgot about something. This is just a function. We need to call the function. Sorry about that. So in the draw function here, we need to call draw key points. So to do that, we just the detected pose. I will save this. I can restart the server. Remember, with Control and C here in the terminal, you stop the server execution, and then you just write node space server.js. I will restart the web page, and voila, poop, I'm detecting my key points. Maybe those are like, I look like a clown, but it's detecting my shoulders, it's detecting my ear position, it's detecting my eyes, and it's detecting my nose. Then we can add, I will send you the code with the lerp function to actually smooth this. But this is working. This is fantastic. Now that we have this, I will also include the definition to, actually, I have it somewhere. Just let me look for the draw skeleton, so I don't waste time explaining you the skeleton function. No, actually, we'll do it. Let's implement it. It's not a big one. So this is, that is the code. So let's do the function draw skeleton. The draw skeleton is pretty similar. So to draw the skeleton, we will actually copy this. We will loop through all the pulses detected. And inside this loop, we will let skeleton, and skeleton will be equal to poses I that skeleton. So before we said like let poses pose. Here we're accessing the object skeleton. So with this we can add another loop for let j equals 0, j less than skeleton dot length j plus plus. So inside this nested loop, basically here we can say for each skeleton detected loop through all the body connections. So here we just said like for each connection that you found, we will say let part A equals to skeleton j and 0. So basically it will just find like the first element of one part of the skeleton. This is why, I mean, we will iterate through each part. So a shoulder, and the shoulder has like one specific connection that is 0, and we will have another one that is part B. We'll call it part B, and this will be a skeleton at J position, but this will be 1. So it will say, it will give you the end point of that connection. So this is basically like a graph with a start and an end connection. And for this, we will say that stroke, we will set the color. We can do let's do something like a nicer color. We can do like a, yeah, like a cyan. So it's like 0 at 255 at 255. And then we will say that stroke it will go from part A, that position, that X, we will draw a line to part A, that position, that Y, to part B, that position, that X, to part B, that position, that Y. So this will just draw a line. This will draw a line from, and I will put it in parentheses, like connection, like start point at X, start point that Y, to end point that X, to end point that Y. So that's the only thing that this is doing. And yeah, this will draw just a line. I will also reduce in the key point this to 10, so it doesn't look that big. So this will draw the skeleton. Let me put some order to my code so it looks all tidy. And we need to call also the function here. So the draw function at each loop will show you the video. On top, it will draw key points, and this, again, really standard code, draw the skeleton. So again, let's see if this works. I just need to save. I think we don't need to stop the server. Let's go here and reload this. Yes, this is, working, but it's not showing. Am I missing something? This is calling draw skeleton. It's showing the points, but not the skeleton. Did I do something wrong? Part A, part B. The stroke is that. Oh, sorry, I put stroke. This was my typo. Sorry, this is line. Yeah. Okay, here we go. So you see, it's detecting my pose. So let me go further away. It has a pretty good detection, to be honest. Like it's detecting. It has some yeah, like noise, but don't worry about that. So you see, if it detects me sitting, it detects my arm, so it works. For some reason, it's having problems, probably because I'm wearing like too much black or something. But it's working. Like it's reliable. We're getting something quite reliable. Okay. So now we're done with this. We're done with Postnet. So if you follow the code, or if you copy and paste the code that is saved on the Dropbox file, here, for example, if I click or pre-visualize here in the Explorer, you see that you have the code already. So if you go to the link, the Dropbox link that I dropped in the on the chat, you will be able to run this, like everything, right? We need to implement one final thing. That final thing is actually the one that will create a request, and this is like super important. Here we finally can transmit the data, name the detected pose to our server. We will do this by requesting stuff to our server. How do we do this? We don't, so we don't want to get like an error saying that, okay, we're requesting something with no information, so this might crash our server. So, and also because this is, imagine this, that this is like a stream of different flows, right? You will be transmitting data, getting data. So sometimes you will get data, sometimes you will not get data. You need to make this happen like in different, let's say like streams. So you need to make sure that you don't get like an error and things can work at the same time. It's like similar to the threading that I showed you in the last session. So in this case, what we want to do is to create an asynchronous function. And that asynchronous function will work outside, because it will work outside the loop. I mean, it will be called by the loop, but basically it will be executed at its own pace. So this is why we need to say async here. Function is an asynchronous function. Draw skeleton and draw points, key points are synchronous function. This is an asynchronous one that doesn't necessarily is like coordinated with the other ones. And this will be get receive, right? We will call it like that. This function will do the following. We will create a constant we will call data, and data will be equal to poses. So remember that here, when we call Postnet to work, to start working at the beginning of our code, we are saying that the results that basically are the poses that we are detecting, assign that value to the poses array here. So we will get that information inside that variable. So we will say now that a constant, an internal function constant or variable data, this local variable here, will be equal to that post information. So we will assign the info from posts variable to data, because we will now send that information as our, let's say, like handshake with the server. How do we do that? First, we need to create a JSON file that we will call options. Options will be equal to, we open curly brackets, and we will say like method. We will post information to our server. So we will send information to our server. We will post information. We will write these headers. This is also like very standard thing. So headers will be like content type, because we need to specify what type of information we are sending. So in this case, it will be like application / JSON. And the body, remember that in our server we are plotting this like the response as body. Actually, we're doing that. We're assigning body to JSON. The body value is JSON dot stringify data. This is an important, or probably like the most important line, because what this is doing, let me see if I'm okay with the parentheses. That's the parenthesis that closes the, yeah, that's it. So this line post the type of, let's say, method. Send info to server. We have here the headers. So basically this tells the server that our info is in JSON format. And then we have the body, that is the data that we are sending. And what we're doing here with JSON, that is a method, a stringify, we are, it says over there, when you put your mouse on top of stringify, it says like converts a JavaScript value, that is our data, to a JavaScript object notation JSON string. So basically it's a string formatted as a JSON file. So we're sending a string, like a very long with all the data, but formatted as a JSON string. And with that, we have options. So now we will say const response await. Basically, we will execute this if we get this, again, like typical of asynchronous functions, because they are not sync with the other functions. We get information, and basically we can have, basically this is all something that are called like promises. I can point you to more resources to learn about this. So basically we will await until we get a response. So this is why here we call with fetch. Basically we want to fetch information from our server. From where? From the API 1 endpoint options. So this will basically fetch information, but at the same time we're sending information. So that is a little bit weird to understand, but I hope it's clear when we make it work. So basically we call this method fetch to send the information. What information we're sending? This. And here we can say const JSON await response.json. So this is a method that will just because with this line we are requesting info from the server, but at the same time asking for info. Here we get the server response, and here we print the response from the server in our console. So this get received function, we need to call it somewhere, and we will call this in our draw function here. We start asking for info in our server. All right, this is okay. So let's see if this works. So again, this method is a little bit complicated, but you will understand what is going on right now. Here, we make a request to our server, calling this, basically this is executing the API 1. And when we execute the API 1, so basically here it will, oh, someone is like entering this endpoint here, we will plot the information that is being sent, like by the, that we're transmitting. In this case, the information is this one, the data, AKA the poses. And let me move this here. And the server will get that information, and it will say like data in is that request.body, and it will say that poses, the global variable here, is equal to that data. So we are storing in the server the information of the poses. And then we're just sending a response to our, back to our ML that will be the same data, to see that we are actually having that handshake. So you will see the information here, but also the information in the console of the website. So let me format my screen here. I will put this code here. That is good. So we see both things working. So I will also put the developer tools, the console. Yeah, it's giving me one error here, but it's not affecting the. So it's exactly when we want to change the status. Actually, let me just delete that. So it's in the model ready. Model ready here. Just let me comment this so we don't get like nasty errors. So I commented that the server is running. We have the console here. I will just clean it. I will restart the web page. So voila, look what is going on. We are sending, because we're executing get receive, and in our server, because we know that something is being called, we get a request from someone that is actually accessing through here to API 1. What you see here is the result of the console.log request body. Basically, the request.body, that is the information that we sent here, body, are the poses, the information of the poses. But at the same time, what we're doing from this function here, from this endpoint, we are sending back to my website the information that we are getting, right? So we're sending the information, but we're getting back the same information, just because of debugging purposes, right? So you can see here that this is actually getting one post. It says like post, the score is like 0.43. It's detecting 17 key points. So you see the key points here, and you can see that these are JSON objects. It tells you that the score for the nose is 99%. So it's like really confident that actually is detecting my nose. The left eye, the right eye, the left ear, the right ear. You see that you have like less confidence for the right knee because the camera is not looking at my right knee. So you see the confidence is 0.0059. So it's like nothing. You see that the right elbow, for example, is like 70%. You get the wrist. That is part of the skeleton, but well, yeah, right wrist, for example, is like 5%. So it's like the left wrist is not detecting. I don't see it. Anyway, so you see that the ones that have more than 20% confidence will be shown, will be drawn here. So this is why, yeah, as soon as I lift my arms, I start like actually showing my arms and so on and so forth. So we know now from the server side, this is working fantastically. So our job on the JavaScript side is done. And that makes me very happy because it's working. So we're implementing machine learning. So you can, in the same way that we just did it here, you can use like other algorithms. So let's leave this actually running. I will leave this running because now we need to move to Unity. And that is not like too complex, but it has like some complexity. So you see we're getting like the same results as here. So good, awesome.